All right, y'all got any questions for me before we go into the next concept?
Yeah, can I see that one from the beginning? Like
Mm-hmm.
how to get the answer.
Oh, let me show mine. Oh, you was talking about this one here, or you want to see my actual total?
Average total.
Okay. This one. So you would take AVG, the function, and then you would take the function then you would take the column and put that column in parentheses.
Which would be total amount, right?
Yep. It would be total amount. And then you would have your status as well in your select statement, because that's what we're going to group it by. So it'll be select, you get rid of what you don't need, keep what you need, and then the AVG, and then total amount in parentheses as total average total amount, or whatever your alias is, your status, and then you're getting it from your orders table. This is our filter where order date between these two values, and then we're going to group by status.
Yeah, I think that's what I was missing, the parentheses and then the between. I did the date.
Okay.
But I just said greater than.
That's, I can see. Did you do like, because I've seen people do it like that, and I'm like, I didn't even think to do it like that, but it makes sense. Did you do like greater than this number and less than that number?
No, I just did where order date is greater than 2024-01-01.
Oh, okay. I can see that. Because that way, also, it's not wrong, but also consider that would also potentially include 2025 as well.
Right, yeah.
Yep.
Okay. So just 2024.
Yeah. But the thought process.
With just 2024, then yes, use the between so it can stop at December 31st.
Period.
Gotcha.
Any other questions, y'all? Okay. Now that was aggregate functions. That's something that that you need to, be aware of, because when you start interviewing, you might have to do a tech assessment. One of my students from last session was telling me about how she, like I said, she's an insights analyst, and she was saying how she was like during her interviews, and some of the questions that I was telling y'all they literally asked in them interviews. So that's a common thing that you might have to do. And because when you think about it, think about all the business cases that can be used with it. Okay, what was our average amount last quarter? What did we spend last quarter? Or whatever the case is. So yeah. The next one is joins. Joins are a big one for y'all as well. Be able to competently just explain the difference between all four of these joins. And you might not have to go into detail, but be able to explain it. If it takes for you to having like your cheat sheet pulled up, if it takes for you to have something as a point of reference, then it's totally fine. But it's 4 different types of joins. You got your left join, inner join, right join, and full outer join. Your left join only brings back matching data. All the data from your left table, matching data from your right. Your inner join brings back only matching data from both tables. That's why it's showcased here. That data has to exist in both of those tables for it to be returned back in my output. My right join, all the data from my right table, matching data from my left. My full outer join, it does not care. Give me all the data from both tables or all tables, because you can have more than 2 tables, whether it's a match or not. Period. And this is actually the question that she was asking her interview. And I was like, they love that question. I still be on interviews and they ask it. But yeah. Also, this is where it comes into play with you getting a good understanding of data relationships as well. Because data relationships are going to help drive joins, but it also is going to help you in all the way around within data. From Power BI to Excel to Python, they all care about data relationships. So the quicker like it becomes natural to you, the easier that other stuff will be as well.
Do you provide in our coaching sessions like a list of like questions that'll be constantly asked in interviews and things like that?
Not in a detailed way, and only because it's not like it can vary. Like, and
Yeah.
what I mean by that is, it's like, okay, I can give you what I have seen and what I experienced, and even when I sit on interview panels, the type of questions they ask. But it can vary by organization, it can vary by team, company. Like you might honestly they'll get an interview to where you might be asked a few questions and then that's your interview. And when I say a few questions, it might say something like, how would you solve this problem? Or how would you solve that problem? And then you might be on a interview to where you actually have to do a technical assessment. And mind you, nobody is just gonna spring it on you. They're gonna tell you in the well, they're gonna tell you in the beginning if you have to do that or not. So as far as me, like I will guide regarding like, okay, this is common, this is a common thing in data all the way around. But what I think it's a fine line between like I have to know this, I have to know that, I have to know that, and then you might get there and it's like, oh, this don't look nothing like that. Like,
Yeah.
you know what I'm saying? So it's kind of like because I see stuff like that all the time. Like I would scroll through LinkedIn and it's like these are the common themes, and I'm looking like some of them are, but I've never been asked that. Or some of them I have been asked. I have, so it's like people like obsessed in your interview might vary. Depend. You might deal with a manager that don't even want to interview you. That's literally like I've seen his or her resume. I just want to have a conversation. So
Yeah. Okay.
you know, I think that what will help you and what will, but the way that I always got, even like for example, the other day, like if you come to me, this is the job description. This is what the role I'm currently interviewing for. Let's go through this JD and job description and let's see. Okay, let's look at it from the flip side. If I'm giving you this job description, I'm clearly trying to solve this problem. So let's frame you in the best position to show that I can solve this particular problem. Is how I do it. Like, okay, what they looking for? Okay, now let's go from there. Let's go from like the end goal and then work backwards. What are y'all looking for? What problem y'all looking to solve? And let's frame it in that way. And it helps you be more prepared because it's like, okay, I can lean in on what I already have and I can frame it in a way that's like I'm intentional about solving this problem as opposed to like a catch-all. Like, cause you can sit up on an interview. I done been, I'm not gonna get back on it, but I done been on interviews before, and I can literally tell that they done went down this list. Like I can have one conversation, and I know you done went down this list. I was on an interview with one person in particular, and his about me was literally like 9 minutes. Like he literally went from like every single job he had and like went through every single in detail about conditional formatting. Oh, wow. It was so weird. And like I could tell that like you literally went down like some kind of list and we wasn't even looking for that. So like from that moment I'm nonstop. Yeah, he didn't nonstop, just kept going. He didn't stop. Like when we got off the car, I'm goofy. So I was like, he wasn't gonna stop. But I can tell, like, it's like I can almost tell. So the way that I always coach out is like, okay, let's look at this job description. And if I'm hiring, this is like in my company, if I'm hiring to solve a problem. So let's figure out what the problem is and let's work from there. But yeah, he ain't stopped. He ain't stopped. He ain't stopped. He ain't stopped. He just kept going. It literally was like 9 minutes. So that's how I really like, and he didn't get it. And it wasn't no shade, but it's just like we weren't even looking for that stuff. Like, it's supposed to be a little kind of like a little elevator pitch, and they just keep going. Yeah. Their entire life. Yeah. So yeah. Like, yeah.
I got you.
So how we did it the other day, that's how I'll be telling y'all how to do it.
Okay.
Yeah. Like, let's start from there and let's go from this. So yeah. So this inner join, that inner join brings back common data from both tables. If the data exists in this table and the data exists within this table, I expect it in my output. Anything that you put in your select statement is going to show up in your output. Select column from this table. Inner join this table. On. What are you joining these tables on? That's the data relationship. On E dot department ID equals D dot department ID. The department ID from this table, the E table, the department ID from my departments table. These are called aliases. I'm going to name my table this so that when I get deeper into my analysis, if I have 60 lines of code, it sounds crazy now, but it's not going to be crazy, y'all. In about 6 months when you in your role. When you good in your role. If I have 60 lines of code, I know that whenever I reference this table, whenever I reference E, I'm talking about this table. So those are your aliases. Left join. All my data from my left table matching data from my right table. When I say left, I mean the table to the left of my join syntax, period. The left and right used to be so confusing to me because, like, what are you talking about? But it's literally the table to the left of your join syntax. How do I know which table to use as a left table? What table do you need all of your data? What is your priority table? If you're dealing with patients, if you're dealing with members, if you're dealing with customers, and you want all of that data, regardless on if they exist in another table or not, then you will use a left join. Your left join and your inner join gonna be that's it. That's what you're gonna do. But you still have to know how to explain a right join and a full outer join. But your left join and your inner join, those are your most commonly used joins. That is what you're gonna do. And only because, like I was saying last session, when we learn to write, we learn right to right, left to right, left to right. So yeah. Any questions on those joins? Your filters, anything you do, go right under your own statement. If you want to include an aggregate function, a case statement, any of those things there, it still goes right in your select statement. So that is a join. Joins should be high priority for y'all. I promise you. I promise you. If you don't walk away with nothing else, walk away with it. Any questions on that? Let's go in our patient healthcare table and let's join two tables, and then we'll get into our use case for tonight.
What table did you say?
Go in your healthcare system database. I didn't get a table deal. Mm-hmm. Oh, Erica, Erica, we hear you, Erica. Okay, I want the patient first name, last name, date of birth, gender, test name, test date of all abnormal MRI tests. So first things first, data investigation. Go and figure out which tables house your data. And I want all the patient data, regardless on if they have had a test or not. So first, am I sharing my? I didn't mean to. So first things first, which tables answers this question?
Patients table and medical tests.
Yep. So select your top 1,000 rows from your patient table. I want all the patient data, regardless on if they have a test or not. I want all that data. Did y'all heard Stephanie? She said the medical test in the patient's table. So go and gather your data first, and then go and start filtering out your data. I'm gonna go on mute. Let me know if y'all have any questions. I want to talk through something. Okay.
Okay, so this is where I got stuck last week.
Oh.
So the select.
Mm-hmm.
So just looking at the example on the screen, the left join, select e name and select e name, comma the department name. Those are the two tables that's being used.
The E is the table. These are your columns. No different than how you've been listing out your columns, Keisha. Literally, no different in this. We already got these columns. Like, this something totally different. But I'm saying, like, yeah. Why I'm trying to connect? Okay, there you go. This how you've been listing out your columns. So don't get lost in the sauce. What I mean by that is still very much so list out your columns just like this. But the only thing you're going to do different is you're going to have to identify or label which table you pulling those columns from. You don't have to unless that column exists in both tables. But you're going to have to identify what table that column is coming from because you have more than one table. Whereas in here, we only got one table. So we already know it's coming from that table. Mm-hmm. But in your join, you have two, you might have three. So it's like, okay, let's label out these columns so we know where to source them from. But that's what I mean by like, don't like overthink it because you've been doing it. The only difference is now is I can either get data from here or I can either get data from here. So tell me which one you pulling your data from. That's the only difference. Right. Did that make sense?
I mean, I understand the concept. It's just getting started. Like, I know we're using patients. I know we're using medical tests.
Yep. Okay, let's do this. What are you joining it on? What's the data relationship? If I'm using patients and I'm using medical tests, what is the data relationship between them tables? That's what I actually thought you were stuck on. What's the common field between both of those tables? Anybody can chime in. What's the common field between my medical test table and my patient's table?
Patient ID.
Yep.
Yeah, the patient ID.
Yep. So that's your data relationship, Keisha. That's what I thought you were stuck on. I thought you were gonna be stuck on that own because I think that's what you got. They got you last week.
I feel like I ain't even been here for 4 weeks. Like I don't even know where to get started.
Let's talk about it. That's why I always use this to like go back. Let's go back and go over this before we like. Yeah. So this is mine. I select this literally what I did. Okay, I did patience. So let's walk through it.
Okay. So yeah, that's what I have up first.
Yeah. We got our patience. So I got rid of that top 1,000 because that top 1,000 is a limit. So, okay, I'm out of there. And I'm gonna name my patients table P. Left join. What we say, y'all? Medical test. Medical test. M. On. I did the P. If the patient ID is the data relationship, P dot patient ID equals M dot patient ID. Now up here, I'm getting an error because it's basically like, baby, this ambiguous. So this example that I was telling you a minute ago, I can either get patient ID from either one of these tables, so I got to be specific. Which table? And I'm going to say P dot. So I got all of this data, but I also need my test name. So I'm literally listing out all these columns in my select statement. Mm-hmm. And this is what I was explaining to you, Keisha. I was like, don't get it confused from what you already been doing. Test name, test date. Test name, test date. What else? Result. It gotta be result because I need abnormal. Okay. And there we go.
Just like that. Mm-hmm. Okay.
Were you overthinking it?
Yes. Overthinking it. Okay, so
I haven't filtered nothing,
okay,
but
go
this
back
is it.
To when you had did the line 12 and line 13. I seen you had changed, so it was from medical tests.
Yep. I started from my patients table because my patients table is going to be my priority because I want all the patient data. I want all of that data regardless on if they have a test or not. So I'm going to use my left join on my patients table because that left join is going to pull all my data from my left table. This is my left table. This is the tables in my left of my join statement. So that's what I did there. Then I came down here and I joined that medical test table. But what I'm gonna join it on though? On the patient ID.
So the own is gonna be the primary, the
Yes. Keep talking. Yes. If I'm joining this on the primary key of this table, you right. On the primary key of this table, it's gonna be the foreign key on another table.
Right.
Yes.
So will it always be like that? And when we're always using two tables, will it always be the common key between the two for the on statement?
You might have to link a third table to get to that one. And what I mean by that, think about it like almost like a detour, like in your natural, you driving, and I'm still going. This is still my very much so my destination, but I got to go through here. I got to go through this table to connect that table. Mm-hmm. So you might, with a join, you might have to join 3, 4, 5, and you literally like keep listing them just like this: left join on, left join on. Like you literally keep layering it. When I tell you, Keisha, don't nothing hardly change. Like once you get like that baseline concept and understand this, everything you do just gonna keep layering or extending just a little bit from where you already are. So you might have to go through one table to get to, what you're trying to get. But yeah, overall, that's going to be your work through. And when you're on interviews and stuff, just literally talk through it. This is the data relationship. This is what I'm doing. So that's literally what I did. I went and I selected my top 1,000 rows and I literally built on that, just like that. Now, I said of all abnormal MRI tests. So I'm gonna come down here and now I got a filter. So where result equals abnormal. Okay, this worked. All right, now I only need MRI tests. So then I'm saying and test name equals MRI scan. I'll just be copying it. And there you go. Start from 1. Oh, I didn't even do that. Start from 1. Okay, this works. Now let me add this. Okay, this works. Now let me add this. Okay, this works. And it just makes it easier to break it down in small concepts like that. Yep. Any questions on that join? Uh-oh, what I'm doing? Okay. Now this one. This is the new concept that we'll learn. One of the new concepts. We'll learn 3 new concepts, but the other 2 are essentially extensions upon what we already have done. So this is the only brand new one. So subqueries. What is a subquery? A subquery is literally a query inside of a query. And it's used to perform operations that require multiple steps. Essentially, when I need to lean in on the output of one query to use for the analysis in the other query. This is an example of a subquery here. When you're looking at this, you see 2 different queries. You see one query, and then you turn around and see the other query. Now, when you break this down into 2 different queries, what is this analysis doing? Like, what is it doing? Let's start from here first. This one right here. What is this doing?
Finding the average salary amongst all employees.
Yep. This is literally giving you the average salary from the employees table, period. What is this analysis doing? What is this query right here doing? This is the second part. What is this query doing? Just look at this part right here.
Select from where?
Where what? What's the condition?
The salary.
What about it? You right.
We're trying to find out the average, the salary that's more than the average salary.
Yes. Yes. I'm trying to get all the employees who make above average salary, period. Yes, ma'am. Because like Jamal said, this part right here, this calculates the average salary all day long. Select average salary from employees. I got my query here. I got my parentheses around it here. This query here selects the employee ID, employee name, and salary from the employees table. Where what though? Where this column where salary is greater than this value. That is a subquery. I can't answer who makes above average salary if I don't know the average salary. So anytime you have to use a analysis that depends on the output of another analysis, that subquery is a good way. Subquery and a CTE, which is actually what we'll do tonight as well. But subquery allows you to use the output of one query to do your other query. The thing is with subqueries, you can only use them in this section. Like once I use it in this, like once I use it here, I can't reference it anymore. You know, it's just in my code. That's it. Same thing with a CTE, which I'll talk to you about that in a minute as well. But a subquery, I'm literally dependent on the output of this to calculate this. I got to calculate this first, which is the average salary, and then I'm going to use that as a condition, basically. So for this one, y'all, let's go back to our orders DB. And I want the use case here. Okay. So we are back in our orders DB. We're back in our orders DB. And for the use case, I need all credit card payments that are above the average amount. So first things first, and this is only one table. So first things first, do your data investigation and figure out which table answers this question. I need all credit card payments that are above the average amount. I need a list of all credit card payments that are above the average amount. Which table? Have y'all found the table yet?
Payments.
Yep. So select your top 1,000 rows from your payments table and start building out your subquery. Build out your subquery first. Let's do our subquery first, and then we're gonna go and add our filters to only filter our credit cards. But yep,
please show
payments table.
Where payments is. I'm very lost right now.
Let me. Are you in the orders DB Dale?
I'm in. No. No, I'm not. That explains. Okay, yep. Never mind.
We moved. We over here now. We moved addresses. But the table is the payments table. Stephanie identified it. And then select your top 1,000 rows and build out your subquery. I need all credit card payments that are above the average amount. And if y'all want to walk through it, we can. Y'all good?
I'm good. I had to figure out what I was doing wrong, but I got it.
Good. Do you mind sharing your screen so we can walk through it?
Okay.
Stop sharing.
At least
Stephanie, you probably got it. You probably got it. You probably got it. Okay. Yeah, this is perfect. Okay. So, oh, okay, yeah. So she has her select statement. She selected her top 1,000 rows from her payment table. On line 7, she starts to get to her subquery, where where her amount is greater than the select average amount from the payment table. This is perfect. This is perfect. And now when you filter out your credit card payment, Stephanie, mind you, this subquery is already considered a filter. Because on line 7, we say where. So we already filtered. So our next filter going to be and. Our next part of our thing is going to be and. On line 9, you're going to get an and. Instead of where, payment amount, payment type, depends to this credit card, you're going to say and. But yeah, other than that, it's perfect.
So what I need to change?
You don't need to change nothing. When you filter out the next step, you got the first step, this works. You tested it, okay, we good. The next step is we only want credit card payments. So,
Okay, gotcha.
yeah, so I was saying the filter that your subquery is technically considered a filter because you started out with where. So you wouldn't say where payment method equals credit card. You would say and payment method equals credit card.
And
Yep. Yep. That's all I was saying. But yeah, this is perfect. Do you feel okay doing this?
I do.
Okay. Does anybody have any questions after looking at Stephanie's code? Good job, Steph. Good job. That is a subquery. A subquery, people also call them nested queries. I'm gonna type it in the chat. They literally are the same thing. They literally are the same thing. Nested query or subquery. I got a query inside of the query. I need the output of this to answer this analysis. Yeah. Any questions before we get into the next objective for tonight? All right, views. Now, what is a view? A view is a virtual table. It is a fake table. And what I mean by that is it has the rows, it has the columns, but it doesn't actually store the data. Whereas our table stores, oh, our table stores data. Views do not store data. Your views are housed in this part, right underneath your tables. We got a portion down here called your views. So we got our tables and we got our views. Views do not store the actual data, they store logic. So, what would be the purpose of a view? Let's say you are in a position to where you have to perform a specific analysis every month. And this month, at the beginning of the month, they want to know what was the total amount of this or what was the average rate of that for that time period. Views allow you to store that logic in a way that you could easily just go and retrieve that data anytime you need it. I can easily go and retrieve that data anytime I need it, and it already stores my logic that I have. Already stores my logic. It's consistent, and if I need to take that view and join it to another table and add some more conditions, add some more logic, I can very much so do that because my logic already defined. So view stores logic. It makes those very complex queries easy to retrieve. You don't have to keep going through that same brain logic over and over and over again and using that logic and comparing it to something else. But I could just go and pull my view whatever I want to that view instead of all my logic. Another benefit of them is they provide a level of data security. I had a student, I think it was like 2 sessions ago. She's in trucking. She's in the trucking industry. And she's already very heavily exposed to data from the reporting side. Like all she does is reports, reports, reports. That's all she does. That's literally it. But she's also having to come in and change the reports because unfortunately some of the data that's been published out in those dashboards, they use Power BI. Some of the data that's being published out in those dashboards is not right. It's wrong. So you got these people that are using these dashboards and the data is not right. So her job is essentially was to come in and fix all this. She said that in the midst of her doing like all of her data investigation, she realized that the back end of those reports were not actually connected to tables. They were actually connected to views. And she was saying that she was confused about what the difference was between a view and a table. And I was explaining to her that a view stores the logic, a table stores the actual data. So if your report is connected to a view, you're still very much so getting the data, but you're not getting it from a table, you're getting it from a view. So therefore, if you need to go in and change that data source, you got to change your view and not the logic to your table. And I said all that to say a lot of places opt in to use views on the back end of their reports because they are supposed to have a high level of security. Meaning that if I give a report access to this view, they don't have access to all of the data that the table might have. They only have access to that view. So with that being said, she's like, okay, that makes sense. And I taught her how to alter a view to make sure that whatever your logic showing up in your dashboard is like right. Like you can't, well, be surprised, be making decisions on data or dashboard on data, and they make these decisions and they could be wrong. And you have this happening in Fortune 500 companies where like you're making decisions based off of flawed analysis, like stuff be wrong. So she had to go in and like change all of this stuff to make it right. So views support data security because I'm only giving you access to a view and not all this data that houses this housing is happening. Another benefit is data integrity. Like in my role, we update the database like they do a refresh like every couple of days. Let's say I have a report, again, like a Power BI dashboard, and my dashboard, I'm building out this dashboard in the back end of the logic, I'm saying something like select star from this table, which is why you're not supposed to do that. Because if I say select star from this table and that table changes, the column change, my report will break. So a view allows you to keep that logic consistent regardless of whatever that table is doing. I'm going to keep my logic consistent because I'm pulling my data from a view and not a table. So a view is basically a virtual table. And with your view, you create your logic to say whatever you want to say. Your join, your area function, your conditions, anything you do goes right into this view. And if I want to take that view and join that view to another table, I can do that easily instead of having to rewrite that logic again. Any questions? Now for this one, let's actually stay within our order CD. Also, common practice with a view is you always do, where my mouse at, y'all? Oh, there you go. You have to create view, and you got to start your view. Um, you got to start your view as like view like this, or either VW, whatever your view name. create view, your view name as, and then whatever your logic is here. So let's say we send out orders, customer order CTE. Okay, and I'm going to write the use case in the chat. Okay. Create me a view with customer ID, customer first name, last name, all the customer information basically. But I also want the order date, total amount, and the status. So I want all my customer information plus their order information. Create a view with it. Do your logic first. And let's only focus on customers from Colorado. I need all my customer data and their orders.